Oh, good evening, Observatory fans. Took a day off, but for a reason. Because I was talking about Jupiter, right, and Io, and Roma, speed of light, yada, yada, yada. It occurred to me, I once looked this up, the whole Shoemaker-Levy 9, the comet that slammed into Jupiter in 1994. A few oddities about this story. Those of you who, especially one person today, he will not back off, right? Give me an explanation. Show me the equation that proves that the speed of light in the sun's been worked out. No. It's a well-established no. He will not accept, right? Convinced, doesn't need an equation. It's been proven, right, over and over. Telling the sun takes 4.6 seconds to radiate light, the distance of its own diameter. Gets really riled up because it's about common sense, isn't it? All right. Something takes 4.6 seconds to radiate light, the distance of its diameter. But this bulb, its diameter should be 1, 2, 3, 4.6, a bit faster, would be 1, 2, 3, 4.6 seconds. That distance, right? Now look at this. How many diameters? Basketball, how many times do we have to do this, right? Look, this was the sun, pound for pound, right? It's going nowhere. It'd be about here by now, right? Look, common sense, mate, common sense. That and the fact that there is no equation that proves it, right? That's why it's an absurdity. But if you're content with that explanation, and that sun, your star, radiating its light at that speed, then yeah, what is there left to say? All right, enjoy it. Particularly my hot chocolate, coffee. So, Comet Shoemaker Levy 9. All right, it was spotted in July 1993. Right, 1993. A year before impact. This thing broke up into 21 fragments, right? 21 pieces. They reckon that happened on the previous pass when it passed Jupiter, right? How on earth, right, does something break up and string itself out for over 31 million kilometers from the first to the tail end Charlie, right? 31 million kilometers. Never heard that number before, right? But I worked it out because it's quite easy to work out. It's the numbers again, isn't it? They were traveling at 60 kilometers per second, right? This is how fast this meteor was traveling, right? 60 kilometers per second. 60 kilometers per second. 1 kilometer per second is 3,600 kilometers per hour, right? 1 kilometer per second is 3,600 every hour. It's 3,600 seconds in an hour. 60 kilometers per second, which is what these meters were traveling at, is 216,000 kilometers every hour, right? If we multiply that by 1 day, 24 hours, that's 5,184,000 kilometers. The first meteor struck and it took 6 days, right? for the final meteor to hit. That's 6 days. 6 days. 6 times 5,184,000 is 31,104,000 kilometers. That is the distance that they were apart, right? Venus, at its closest to us in our orbits around the sun, when we get the closest together, is 41 million kilometers away, right? First to last was 31 million kilometers away. Anybody who's ever seen footage, and you can see, I don't even know, do they get all 21 in? They actually get all 21 of these fragments in, and they're shining. They're lit up, right? Now, isn't it strange that the whole world was ready because they had ample time to get all the telescopes ready, right? But when the first comet hit, guess what? It hit on the dark side, where none of the Earth cameras, not one single Earth camera, saw any of the comets hit. All 21 hit on the dark side. They were able to get the footage because the Hubble, the Ulysses, the Voyager 2 and the Galileo just so happened to all be positioned perfectly to pick up the collisions, right? Now, NASA, say no more, all right? Not a big deal, not a big deal, not a big deal. This planet here is to scale, all right? Everything here is to scale. That's planet Earth, 15.3 centimeters. We've got Io, and we've got our moon. All right, there's Io, 4.3 centimeters. Our moon, 4.1 centimeters. We know it's our moon because look, there's Daisy the cow. And Jupiter is 1 meter and 67. I wanted to get a Jupiter that would fit this board. So I measured it up and then decided on the number 12. So what I did, I multiplied everything by 12. Jupiter's diameter, 139,822, multiplied by 12. Alexa, what is 139,822 multiplied by 12?
139,822 times 12 is 1,677,864.
So the 1,677,000 became 1.67 meters, all right? And I did the same with Io, 4.3 centimeters. The same with Earth. You can work these out. The numbers are all here. I always show my numbers, unlike the speed of light, the equation for the speed of light, which is nowhere to be seen because it does not exist, right? So Earth became 15.3 and our moon 4.1, right? And just so you know, Alexa, what is 1 meter and 67 divided by 15.3 centimeters?
1.67 metres divided by 15.3 centimetres is approximately 10.915.
All right, that's 1 meter 67 divided by the 15.3. Alexa, what is 139,822 divided by 12,742?
139,822 divided by 12,742 is approximately 10.9733.
There we go. So it is perfectly to scale, right? So we know that it was strung out over 31 million kilometers. It just really doesn't look like that when they show us those pictures, does it? Now we're going to get a little bit lower down. Oh, by the way, the best explanation to come up for the breakup in a perfect stringy line that ran 31 million kilometers. Highly complicated orbital mechanics we don't understand. Right. What kind of orbital mechanics makes an asteroid or a comet break up like that? Now you see that over there, it says a human hair. On average, 75 micrometers, not millimeters, micrometers. So we're going to go down here now, and we're going to see how big the comet actually was. Right? Now, they reckon it broke up that when it was intact, possibly 15 kilometers, 17 kilometers in diameter, that kind of a thing. And when it broke up into 21 fragments, right? Some of them are saying that the biggest fragment to hit was 2 kilometers in diameter, right? So 2 kilometers in diameter, the biggest fragment to hit. Right. Now, this is 1 centimeter, right? I go like that, and I get it right. That's roughly 1 centimeter, right? That I went for 1 millimeter. So the piece of chalk kind of went pretty thin. Forget it, that's about 3 millimeters, okay? I went really, really fine, really fine. Just about get 1 millimeter, but the little, because it's a little bit furry, the chalk, right? It goes over and spills over to the 2. So that's the closest you can get with chalk to 1 millimeter. Because it just, that's still too wide. One kilometer on this scale, right? If the comet that hit was 1 kilometer, if we divide the 1 meter 67, right? That's from top to bottom, the diameter of this planet, by its diameter, we get 0.0119. Now that, Alexa, what is 1 meter and 67 divided by 139,822?
I'm not quite sure how to help you with that.
Alexa, what's 1 meter and 67 divided by 139,822?
I'm not quite sure how to help you with that.
Alexa, what's 1.67 meters divided by 139,822?
This might answer your question. 1.67 meters divided by 139,822 is approximately 0.0119 millimeters.
Right, that is 11.9 micrometers, right? If it were 2 kilometers big in diameter, the meteor, the first one that hit, or the biggest one that hit, that would be 23.8 micrometers. A human hair, on average, has a diameter of 75 micrometers, right? So something at 23, we don't see it. Alexa, in micrometers, what is the smallest that the human eye can see?
From answers.com, the smallest object that a human eye can see is 50 microns.
So 50, all right? So 75 for a hair, we could see it, but when it's on its own, like a little loose wispy hair, who sees it, right? You taste it when it's in your mouth, right? If somebody's hair has fallen on your food. We are looking at 50 is the smallest we can see with a naked eye. 50 micrometers. Now let's go back down here. The smallest I could do to try and get to a millimeter were these here, okay? A millimeter. There are 1,000 micrometers that line. 1,000. So you can imagine how small, right? In 1 millimeter, there are 1,000 micrometers. If it was a kilometer wide, this thing that hit this to scale, this is to scale now, was, let's call it 12, it's 11.8. 12 micrometers, right? Now, you see the damage that they did to Jupiter? Plumes came up, they reckon 3,000 kilometers. First of all, is it not a gas planet? What happens if you shoot around and shoot a bullet into smoke or mist or anything, right? It sucks it in, doesn't it? But there was this massive plumes that came out and then it collapsed in on itself, right? Over 31 million kilometers. This thing in length, right? 21 fragments. The biggest, they say, could have been 1 kilometer in diameter. A couple of thingies are saying 2 kilometers, right? Tiny, 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 right? That amount of damage to this planet, the size of it, it's pretty amazing, isn't it? And it's always who sees them, isn't it? And it is that instigated the planetary defense system, right? To save us from asteroids and meteors. Well, we're going to look at DART next. Remember the rocket they sent up and they blew it into the side of that asteroid? I can't even remember its name now, but I'm going to look it up. Who would think of going back and looking at Comet Shoemaker Levy 9 from 1994 that broke up into a string 31 million kilometers long? And these tiny, tiny fragments that can't be seen, they couldn't even see them, right? Not forget with the naked eye, these things have to be proper telescopes, but they already knew that there was 21 fragments. How did they know? I've watched the footage over and over and over, and it's truly bizarre, right? That the only people to see the images. So, an absurdity or not? You decide. You decide. I'm just pointing out the facts. Right, peeps? We're going to look at the DART, the rocket that hit the asteroid next by the numbers. Coming up probably tomorrow. Later, peeps.